In this chapter, we're going to be looking at quadratic functions. And a lot of this stuff at the beginning is going to be review. We're going to look at standard form versus vertex form. We're going to look at how you complete the square, just as a review from previous math classes. And then we're going to look at how do we deal with quadratics graphically, analytically, verbally, and numerically. That rule of 4 that we talk about in terms of functions. So I want to begin first by just reviewing what the two main forms of a quadratic equation are. First of all, we've got the standard form. And the standard form is y equals ax squared plus bx plus c. That's the typical form that you've worked with most of your time throughout your math career. However, there's a second form that you began to look at last year, and it's called the vertex form. And the vertex form is y equals a x minus h quantity squared plus k. Now, when you look at this, the vertex form is very helpful because it gives us the vertex just in the equation. The vertex is hk, where h is the x-coordinate of the vertex and k is the y-coordinate of the vertex. So that vertex form can be very helpful when we're looking for maximum or minimums because we know maximums or minimums occur at the vertex. So then one question that we want to ask is, if I have something in standard form, how do I get it to vertex form? Or if I've got a situation where I'm in vertex form and I want to go to standard form, how would I do that? Well, if I got standard form and we want to go to vertex form, which is what we're going to want to do most of the time because we're going to be interested in maximums and minimums, is we're going to complete the square. So going from standard to vertex involves completing the square. If I already have vertex form and I want to head back to standard, so I got this quantity squared here, what I would do is I would FOIL and simplify using your rules of algebra. So you'd FOIL out that x minus h quantity squared, distribute the a, and then combine your like terms. So now that we've looked at those two main forms, let's look at the different properties of a quadratic and how it relates to the parent function. So here we've got an equation in vertex form, and I want to relate it to the parent function, which is y equals x squared. And I can see in here, if I compare y equals x squared to this big equation, negative 3 halves x plus 4 quantity squared minus 9, I can see a negative sign, I see a 3 halves, I see this plus 4 in the parentheses, and I see a minus 9. All those additional pieces tell me how the quadratic function was either transformed or translated. Oh, a bell. So now what I'd like to do is I want to compare each of those different pieces. So let's start with the easy one. Since I know that this is in vertex form, I know that this right here is the h and k value. So my vertex is going to be negative 4, negative 9. Remember, when you're inside the quantity squared, it's the opposite. That's the horizontal movement. So this vertex, negative 4, negative 9, tells me I'm going to move 4 units to the left and 9 units down. So we're shifted left 4 units and down 9 units. So that's what the plus 4 and that negative 9 tell me. 4 units left, 9 units down. The second piece that I see here is this 3 halves. This 3 halves tells me I'm going to have a skinnier parabola. Reason for that is 3 halves is larger than 1. If I have a value larger than 1, the skinnier the parabola is. So 3 halves is 1.5. That's larger than 1, so it's skinnier. If I had a 6 right there, it'd be skinnier. And then if I had 8, it'd be even yet skinnier. However, if I had a value between 0 and 1, say 2/3 or 1/2, the parabola gets wider. The final piece that we have here is this negative sign in front. And that negative sign indicates an x-axis reflection. So instead of me being above the x-axis, which is what y equals x squared would be, that's just my parabola. It goes through 0, 0, and is up. This one is going to be going down. So that's how you would determine the different transformations that occur. You look at each piece individually and then break it down.